We're going to be solving polynomial inequalities, and we're going to be using one of these table formats to determine where this polynomial is greater than 0. Now the first step is to factor it, and factoring basically tells us everything that we want to know. In this case, the polynomial factors to x minus 2 times x plus 3, and this tells us that the roots are negative 3 and 2. We know that the polynomial changes sign at negative 3 and 2. In this case, it's changing from positive to negative as it crosses the x-axis at negative 3, and then it changes from negative back to positive when it crosses the x-axis at positive 2. Once we know the endpoints of our intervals, we're going to use the binomial factors to tell us what the sign of the polynomial is in each of the intervals. And so I know that the first interval that I have is between negative infinity, and since this is the greater than notation, I can just use a greater than sign. And I know that my first endpoint is negative 3. So that's my first interval. We're also going to be looking at the value at the endpoint of each interval, which is where it crosses the x-axis. My second interval is going from negative 3 to positive 2. And so that's my second interval, and I know that that interval ends at 2. That's where it crosses the x-axis. My last interval runs from 2 to positive infinity. And so there are my intervals. Now, we're also going to be filling in the binomial factors, and unfortunately we have to fill them in increasing order of their associated roots. The lowest value root is x equals negative 3, and the associated binomial factor with x minus 3 is x plus 3. And so that's what we fill in first, x plus 3. Now I know when x is less than negative 3, for example negative 4, sign of this binomial is going to be negative. I also know that at exactly negative 3 plus 3 is 0, so the value of that binomial at negative 3 is 0. Now when x is between negative 3 and positive 2, I know that x plus 3 is going to be positive. So for example, a number in that interval is a 0. 0 plus 3 is 3, so that's a positive number. Now the value when x is equal to 2 is 5. When x is greater than 2, x plus 3 obviously is positive as well. And so the answer to that one is positive. Now let's do our next binomial factor. Okay, the next binomial factor is x minus 2. I know that when x is less than negative 3, so for example negative 4, that the sign of this binomial factor is negative, and so a negative goes there. Negative 3, when x is negative 3 minus 2 is negative 5, and so my value at negative 3 is negative 5. Now I know in this interval between negative 3 and positive 2, for example 0 minus 2 is negative, and so a negative value goes in there. When x is 2, 2 minus 2 is 0, and so a 0 goes in there. And the sign when x is greater than 2, so for example the number 3 minus 2 is positive 1, and so the sign is positive in that interval. Now down here at the bottom, I'm going to enter my two binomial factors, x plus 3 and x minus 2, and once again they have to go in that order, unfortunately. Now I can find out algebraically what the sign is, what the sign of the polynomial is in that interval. So a negative times a negative is a positive. I can also find the value at the endpoint, so 0 times negative 5 is 0. Between negative 3 and 2, I know that this value is negative because a positive times a negative is a negative. 0 times 5 is 0. And in the interval from 2 to infinity, a positive times a positive is going to be positive. And so there is the sign in that interval. I know the solution to this inequality is going to be all the numbers that go from negative infinity, and this is inequality notation, to negative 3, but not including negative 3. And I also know that on the other side of 2, it's also positive, and those are going to run from positive 2 to positive infinity. Those two sets together account for all the possible values of x that make that true. There we go, and those should be little check marks.